And in this video, we want to have more examples for solving trigonometric equation. For example, we want to solve this equation and find all possible solutions from 0 to 2 pi. When we look at this equation, we know that we have to have only one function, one trig function in any equation. But right now, I see a sine function and tangent function. So, which tells me that I may need to change tangent to sine or sine to tangent to have only one function, one trig function. But there is no formula that I want to replace for sine to convert sine to tangent. And also there is no formula that only change tangent to sine, because the formula that we have for tangent it's sine over cosine, and if I replace the tangent by sine over cosine, I will have another function, cosine function, which it doesn't help me. But when I look at this equation, I see that I have two terms, one term on the left side and one term on the right side. And both of them have something in common. Sine x is something that's in common between these two. So what does it mean? Can I cancel out the sine x from both sides? No, we can't cancel, but we can factor it out if they both are on the same side. So what do? We move everything to one side and let the other side be 0. And to move everything to one side, we need to subtract sine x from the both sides. And when we subtract sine x from the both sides and factor out the sine x, we get this equation. And we know every time that two terms are multiplying together and they are equal to 0, that means each of those terms can be equal to 0 separately, because when I have a times b equal to 0, it means that one of the a or b must be 0. Otherwise, we don't get equal to 0. So we say that the sign must be equal to 0 or the parenthesis must be equal to 0. So we set each of them separately equal to 0. If sine x is equal to 0, the solutions are 0 and pi, because the angles that their sine is 0 are 0 and pi. And if we set the parenthesis equal to 0, tangent x minus 1 equal to 0, and we isolate the tangent by moving 1 to the right side, we get the angles of pi over 4 and 5 pi over 4, because these two angles have a tangent of 1 if we look at the unit circle. So these are all of the solution for this equation from 0 to 2 pi. 0, pi, pi over 4, and 5 pi over 4. And if you want to set them in order, from the least to greatest is 0, pi over 4, pi, and 5 pi over 4. So sometimes you need to convert one function to another function to get only whole equation based on one trig function, but sometimes you may be able to factor out something that's in common out of the two functions. And the only time that we can solve this equation that this side is equal to 0. If it's not equal to 0, I'm not able to separate them like this. Let's solve this equation. It says cosine of 2x plus sine x is equal to 0. We want to find all solution from 0 to 2 pi. As I said, we must have only one trig function. So right now I have a cosine and I have a sine. So it means one of them must be converted to the other one. And I prefer to convert cosine to sine because I have formulas for cosine 2x. If you remember, we had 3 formulas for cosine of 2x. So cosine 2x is equal to cosine s squared minus sine s squared. And it's also equal to 2 cosine of x minus 1. And it's also equal to 1 minus 2 sine s squared. So which one is a better option to replace for cosine 2x now? Since my other function in the equation is sine, so I prefer to replace this one, which only have sine. x. So we replace the cosine 2x by 1 minus 2 sine x and bring down the rest of the equation. Then we will have an equation, but it's a quadratic equation because I have one sine square, I have a sine x, and I have a number. So which tells me that's a quadratic equation. And we can reorder the equation and make sure that to solve the quadratic equation by factoring, the number that's in front of the sine square, or when I have the equation in form of x squared plus bx plus c, if you want to solve the quadratic equation by factoring method, the a, or the number that's in front of the second degree term, must always be positive. If you want to use quadratic formula, it doesn't matter if it's a positive or negative, but if you want to use factoring method, it must be positive. So that's why we can move everything to the other side to make that number positive, because we want to solve this one by factoring. You can still solve this one by quadratic formula, it's okay. But for factoring, I need that the 2 sine squared be positive, so we can multiply everything by a negative or move them to the other side to make them positive. So we will have 2 sine squared minus sine x and minus 1, which is equal to 0. Now I have a quadratic equation. I can solve by quadratic formula, I can solve by factoring. I prefer to do factoring this time. So, and this equation, that's exactly the same as this equation, 2x squared minus x minus 1. So for factoring, we can use X method or diamond method or whatever you call it. Multiply a times c on top and the b at the bottom. And then we are looking for two numbers that if you multiply the numbers gives you -2. If you add or subtract them gives you -1. And the numbers are -2 and +1. Which means that instead of negative sine x, you can substitute by -2 sine x plus 1 sine x. And then bring down the rest of the equation. Now I have 4 terms. Whenever you have 4 terms for factoring method, you can group them by 2. So we can group these together and these together and try to factor out something that's in common from each group. Out of the first group, 2 and sine x is in common. We can factor it out. When you factor something, that means you are dividing that by, you're dividing the whole thing by that factor. And if I divide everything by 2 sine x, I will have only 1 sine x from the first term and -1 from the second term. Out of the second group, nothing is in common except +1, +1. And if I divide everything by 1, I get sine x -1. Now I have parentheses, same parentheses, which I need to have them. So now it's time to factor out these parentheses. And if I factor this parenthesis, I will have 2 sine x from the first term, and I will have +1 from the second term. Now I have 2 parentheses that the multiplication is equal to 0, which means I can set each of them separately equal to 0. And if I set each of them separately equal to 0, and isolate the sine x from each of them, from the first parenthesis, I get sine x, which is equal to -1/2, and from the second parenthesis, I get sine x, which is equal to 1. Now it's time to look at the unit circle. When we say sine x is equal to -1/2, it means the y value of that point must be -1/2. And this point has -1/2 as a y value, and also this point, which means the x should be equal to 7 pi over 6 and 11 pi over 6. When we say sine x is equal to 1, 1 is this point. which means the x must be equal to pi over 2. And these are all the solution for this equation from 0 to 2 pi. Pi over 2, 7 pi over 6, and 11 pi over 6. Next equation, we want to solve this equation, and it says correct the 4 decimal places for all the answers from 0 to 2 pi. So the equation says the tangent of x must be equal to 3.1044. Whenever we want to solve any equation, we need to find an angle which the tangent or the trig function of that angle should be equal to this number. So this equation tells me I'm looking for an angle which the tangent of that angle must be 3.1044. But I know that this number, it's not in my unicircle or it's not in any of the tables. And I have no idea which angle gives me that number for the tangent. So whenever you see decimal number like that, you need to use your calculator to solve the equation. That's the only option that we have. And if you want to use the calculator, the function that you are going to use is the tangent inverse key. So you are going to type this one into the calculator because you are looking for an angle, which its tangent is 3.1044. So you are going to use the tangent inverse key and you get 1.2592 for the answer. But we need all the angles from 0 to 2 pi. This equation tells you that the tangent is a positive number. And we know in the unicircle, quadrant 1 and quadrant 3 are the quadrant that the tangent is positive. So it means that if I want to find all solution from 0 to 2 pi, I need to find an angle in the first quadrant and I need to find an angle in the third quadrant. An angle in the first quadrant, that's exactly the same answer. But for the third quadrant, since you're looking for an angle in the third quadrant, that means you have this angle plus pi, because third angle means all the angles that are more than pi. So you need to add that number by pi, and pi is 3.14, and if you add them together or use the pi key in your calculator, you get a number about 4.4008. And these are your two solutions in this equation. So remember, if you are looking for an angle in the third quadrant, you always add it by pi. If you're looking for an angle in the fourth quadrant, which is this angle, you need to subtract the number from 2 pi. Let's look at another example. We want to solve this equation. Again, the sine x is equal to a negative decimal number. So that decimal number is not familiar for me, so I have no choice of using the calculator. So if, and for using the calculator, I need to type in sine, use the sine inverse key in the calculator, because I'm looking for an angle which its sine is negative 0.2315, and that angle is 0.2336. But now let's see how many solutions we can have. Since the sine is negative number, I know in the unicircle, sine is negative in the third and in the fourth quadrant. So I'm looking for an angle in the third and looking for an angle in the fourth quadrant. So to find an angle in the third quadrant, I need to add by pi. For the fourth quadrant, I need to subtract the number from 2 pi. It looks that we have a typo here. It should be 0.2336. Okay? And replace the pi by 3.14 or use the pi key in the calculator and then find the solution, which is two solutions, one in the third quadrant, one in the fourth. Next example, we want to solve this equation and find all the solution from 0 to 2 pi. Again, I need only one trig function. If you see sine and cosine, that means one of them must be converted. One of them must be replaced by a trig identity because I only need one function. And the easiest one to replace here is sine 2x because I have no formula for cosine to give me sine, but I have formulas for sine 2x. And the formulas for sine 2x is, the only formula that I have is 2 sine x cosine x. But when you replace this formula for sine 2x, you still see that we have two functions. So what should we have to do now? And there is no way, there's no formula that I can convert sine to cosine or cosine to sine, because all the formulas that I have for converting sine to cosine or cosine to sine are when we have sine square and cosine square, but not the sine and cosine. But again, I see one term on the left, one term on the right. And I see something in common between these two terms. And it means that I can factor out the cosine, which is in common between these two. So, but I need to move cosine to the left side first. So subtract cosine to the both sides. And remember, you cannot cancel anything because cosine is a function and we can't cancel it. So 2 sine x cosine x minus cosine x would be equal to 0. And you cannot also add or subtract these two because they are not like term. But now you can factor out the cosine. If you factor the cosine from the first term, you will have 2 sine x. And from the second term, you just have -1. Now when I see the multiplication of two terms is equal to 0, that means each of the terms can be separately equal to 0. If I set each of them equal to 0 and isolate the function if it's not isolated, like this one, which is not isolated, I get sine x, which is equal to 1/2. Now I need to look at the unit circle to find the answer. When we say the cosine is equal to 0, the cosine of what angle equal to 0? This point and this point. So the answers are pi over 2 and 3 pi over 2. When we say the sine x is equal to 1/2, we look at the unit circle. The sine of what angles are 1/2, or the y value of what points is 1/2. Y value must be positive 1/2. And the answers are pi over 6 and 5 pi over 6. So this equation has 4 solutions from 0 to pi, and these are all the solutions. And if you want to put them in order, you can say pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. These are all the solutions from 0 to 2 pi. Next example. We want to solve this equation. So we always say that we must have only one trig function, which we have in this equation. So we don't need to convert any functions. And every time you see a double or triple angle, you don't need to replace anything for them when you are solving equation. The only time we replace formulas for double angle or triple angle if we are verifying identities. But if you're solving equation, you don't need to replace anything for them. You just need to find root 3 over 3 is the tangent of what function? And you know that root 3 over 3 is the tangent of pi over 6. Because tangent is sine divided by cosine. Sine is root 3 over 2. And sine is 1 over 2. Cosine is root 3 over 2. And if you simplify and rationalize, you get root 3 over 3. Which means that the 3x, which is the angle of this function, must be equal to pi over 6. So you say 3x must be equal to pi over 6. If that's the only option from 0 to 2 pi, but we need all possible solutions. All possible solutions, since the period of tangent is pi, we need to add or subtract this number by k pi or n pi. But that's a 3x. When you're solving equation, you just need x, not 3x. Now what do we do after finding the angle, after adding or subtracting by k pi? Now it's time to get rid of the 3 by dividing everything by 3. And if you divide everything by 3, you get x, which is equal to pi over 18 plus or minus k pi over 3. And that is the general solution for this equation. And if you replace k by numbers, by 0, by 1, by 2, you get all possible solutions that we have for this equation. And since in this question didn't mention that just find angles from 0 to 2 pi, we need all solution. We need to just write with k pi or n pi. And the last example, again, similar to the previous one, we want to solve this equation. This equation is sine equation, which means I need to know that the 1/2 is the sine of what angle? 1/2 is the sine of pi over 6. Let me see. Okay, if you look at the unit circle, 1/2 is the sine of pi over 6 and 5 pi over 6. Which means that this angle must be equal to pi over 6 and also can be equal to 5 pi over 6. But that's the answers if it mentioned find answer from 0 to 2 pi. In this question didn't mention anything. That means I need to find all solution. And since the function is sine and the period of the sine and cosine is 2 pi, I need to add or subtract each of them by 2k pi or 2n pi. It doesn't matter you use k or n or just any other letter. So my angle must be equal to pi over 6 plus or minus 2k pi, or must be equal to 5 pi over 6 plus or minus 2k pi. But I need just x, not x over 3. X over 3 is the angle for that equation, but solving equation means just find x. To find x, since x is dividing by 3, the opposite of divide is multiply. So you need to multiply this time everything by 3. And if you multiply the first equation by 3, you get x, which is equal to 3 pi over 6 plus or minus 6k pi. And 3 pi over 6 means pi over 2. If you simplify, plus or minus 6k pi. And for the second one, we get x, which is equal to 5 times 3, which is 15 pi over 6, plus or minus 6k pi. Or if we simplify 15 by 6, we get 5 pi over 2 plus or minus 6k pi. And these are all of the solutions. But if you need solution from 0 to 2 pi, start replacing number for k and then find all possible solution from 0 to 2 pi.